Now let's look at our homework question number 7. Decreasing rate of cost. Here I do not want to solve it. I just want to explain the meaning and do some analysis. Let's read the question first. It is known that when the volume of a chip is doubled, the cost of the chip decreases by 10%. With this relationship, okay, so here, there is some assumption with this relationship. What kind of relationship? Every time you double the production volume of this chip, the cost is decreased by 10%. So there is assumption here. We will need to explore this later. Okay. Now the question, if the volume of the chip is tripled, how much percent of the cost is reduced? Okay, all right. So now let's look at the assumption. Okay, some hidden assumption we need to explore here. All right. First, from the original question, there is no rate, because here we are asked the cost. How much cost is decreased? There is no rate here, okay, but the rate is hidden. Here we make some assumption there is a constant hidden rate in this question. Otherwise, if the decreasing rate is not a constant, then you cannot solve the problem. Okay? So first here we need to make assumption about the decreasing rate. Okay? The decreasing rate is a constant. Okay. The first step. Second, all right. How to use formula to represent the decreasing relationship, right? The relationship. How to represent it. Okay. All right. The volume of a chip is doubled. The cost of the chip decreases by 10%. Okay. This is an important condition we need to use. Okay. All right. Let me write like this. Volume doubled. Okay. Cost reduced by 10%. Okay. All right. From double to triple. Okay. Yeah, because our goal is the volume of the chip is tripled. Okay. But from double to triple, it looks like not quite easy. Okay. Yeah. So here, let's move one step forward and make one easier step forward. Okay. Now, first, let's consider if the volume quadrupled, how much cost is reduced? How much cost is reduced? Okay? Because quadruple, that's doubled twice. It's much easier to calculate than tripled. Okay? Because we can use this relationship twice. Okay? Yeah. 1 minus 10%. This is when the volume is doubled. Okay? Then you double again, so you need to multiply this number another time. So that is square. Okay? So 0.9, 0.81. So then the answer is the cost is reduced by 19%. Okay? Yeah. That's easy. Okay? But how do we get when the volume is triple? Okay. It's very not easy to get this kind of straightforward deduction. Okay? All right. So we need to go another step forward. Okay. All right, here. Okay. When the volume is double, that's our starting point. Okay. Double means you multiply the original volume by 2. Okay. All right. Okay. Now, next, how many times we double the volume? Okay, the number of times we double the volume. Okay, then, with the same rate, that's the same number of times we reduce the cost by 10%. We establish that correspondence. So that is important. All right, so let's assume we double the volume n times. Then you get 2 to the nth power of the original volume. Okay? Yeah, that's straightforward. Okay. Then this side, how much cost? After the reduction, it becomes what expression? Okay? Yeah. Because when you double the volume once, you multiply the cost by this number. Now you double the volume n times. That means you need to multiply the cost, original cost, by n times. Okay? So that number is this number to the nth power. Okay? This, looks pretty clear. Okay. All right, so now let's use the same approach to apply on triple case. Okay? We triple the volume multiple times. Okay? All right. So the same method. Okay? So if we triple the volume once, we multiply the original volume by 3. Okay? Now we triple the original volume m times. Okay? Another integer number of times. So that's here we use n times. Okay? Different from n. Okay? All right. So similarly, decreasing rate, let's assume x. Okay? So this is the number we want to find. Okay? We don't know. Okay? Yeah. X. Okay? All right. M times. Okay? All right. That's the relationship. Okay? Now we want to connect these two relationships. Okay? Two mappings. Okay? Yeah. Based on, some hidden assumption. Yeah. All right. How do we establish the connection between them? Okay. All right. First, when we do the analysis, we assume both n and m are integers because we double, we triple certain number of times, that number usually should be an integer. Okay. But if both n and m number of integers, these two numbers can never be the same, because this one is an even number, this one is an odd number. So even number, odd number, they can never be the same. Okay. So now we push the condition a little bit forward. Okay. We relax the restriction to be integer for m and m. They could be non-integer positive numbers. Okay? Yeah. Yeah. So we assume even for non-integer positive numbers, this relationship still true. So that's our assumption. Okay, that's if it is a reasonable assumption. Okay, yeah. So you double some fraction number of times. Here, the cost also reduced. Or it becomes that the same fraction number of times of this number. Okay. Looks pretty reasonable. Okay. So we can make that assumption. All right. Now, if you agree, we can relax the condition that both n and m are integers. They can be any positive numbers, real numbers. So now, the next step is much easier. Let's say we change the volume of this trip using two different ways. Okay? The first way, double n times. The second way, triple n times. Okay? Two different ways. Okay? But the result at the end, both ways result in the same volume. Okay? Both ways result in the same volume. Okay. Let's imagine that scenario. Okay. Same volume, right? So certain, multiple of the original volume, okay? That number, okay? Now, how to reach that number? Method 1, double n times. N could be a, positive fractional, positive real number, okay? M could be another real number, positive real number, yeah. So, then, the cost side should be the same. Okay? So now the volume side, same. Okay? Two different ways, but you get the same volume. Okay? Then, based on our assumption, constant decreasing rate assumption, at the cost side, they also should be the same. Okay? All right. So now we establish the equations. Okay. 2 to the n equals 3 to the mth power, and 1 minus 10% to the nth power equals 1 minus x to the nth power. Okay. Okay? Two equations. Okay? So we get a system. Two equations. In this system, let's look at the unknown. Okay? N, M, and X. Three unknowns. Our goal is to find what is X. Okay? All right. So now, if you can solve this equation system, then you can solve this problem. Okay? So I leave the remaining part to you. Okay? Yeah, so because already we almost get there. Only last step left. Okay? Hope you can solve it. All right, so we finish explanation of this question. All right.